Okay, so this is a video on chemical reactions. If you're in your class notebook, you'll be able to see the learning objective and the keywords anyway. So learning objective, evaluate scenarios, whether it's chemical, and we're going to do some physical reactions today as well. Keywords then, colour change, precipitate, effervescence, smell and colour. What I'd then like you to do is pause the screen, have a go at these 3 questions, and then we'll go through the answers. Okay, so name 6 organelles in a plant cell. So we've got the obvious ones: nucleus, cell membrane, cytoplasm, then we've got chloroplasts, cell wall, and vacuole. List the planets in order. So my very easy method just sped up naming, and then obviously you've got planets on the end, but that's Pluto as a dwarf planet. So you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay, and then these 4 are rocky and these 4 are gaseous. Okay, name the 4 parts of the Earth. So you've got the core, and then what you've got with the core, you've got the inner core and the outer core, mantle, and then crust. Okay, so like I said, we're going to evaluate scenarios as whether they're chemical or physical reactions. So first off, what is a chemical reaction? So a chemical reaction is a change in which atoms are rearranged to create new substances. Okay, so we're going to use the analogy of baking a cake to get us started. Okay, so you start with your reactants, the things that you want to react together. Okay, they then undergo a chemical reaction, and in this case we put them in the oven. Okay, undergo a chemical reaction, put them in the oven, and then you make a new product. Okay, so all the same things are in your reactants here as are in your final product. However, they've likely to have been rearranged, so changed slightly. Okay, so if we looked at it as a cake, then also look at it in terms of atoms. Okay, so you've got atoms here, you've got atoms here, and you've got atoms here. You've got your reactants on this side, you've got your products on this side. Okay, and as you can see, you've got 4 blue dots on this side, you've still got 4 blue dots on this side, you've got 2 red dots on this side, you've still got 2 red dots on this side. However, they've been rearranged, they've made something slightly different. You start off with elements and you end up with compounds. So that's what happens in a chemical reaction. A chemical reaction is when the atoms are rearranged to create new substances. So what could we maybe see when a chemical reaction takes place? Okay, and there's loads of different examples on here. Colour change, heat, change in state, another colour change, like a new compound being formed. Okay, new compounds being formed. So there's loads of different things that we might see. More things we might see, so temperature change, you could get really cold or really warm. Colour change or something new, a mass being formed, gas being given off. That's another example of a gas, fire being produced. Okay, so there's 2 different types of reactions we could use. Okay, so if something is exothermic, the reaction will heat up the place, so you'll see a temperature increase. And this is because heat is being released into the surroundings. So what we do is we say exit heat. So we go heat exits. So that's how we remember it. It's an exothermic reaction, it's heat exiting. Okay. Then we've got endothermic reactions. They take heat from the surroundings, so it will cool the place down. And we say heat enters. Okay, so them definitions need to go in your class notebook or in your book. But so you can pause the screen and have a go. But then the next little thing we're going to have is you're going to draw a spider diagram, or you've got a spider diagram. You're then going to pause the screen and you are going to tell me how you would know that a chemical reaction has taken place. Okay, so we might see a colour change. We might see a gas given off. We might see temperature increase. Okay, and we call that exothermic. Or we might see a temperature decrease. And we call that endothermic. Okay, we might see a mass formed. So they're our biggest ones: colour change, gas given off, and a mass formed, okay, or a temperature increase or decrease, okay. So we're now going to move on to reversible or irreversible or chemical or physical reactions, okay. So chemical reactions may be reversible or irreversible. So what does that mean? Reversible reactions are often ones that can be undone, okay. And when we see a reversible reaction, we might see this sign instead of the equal sign, okay. That means that the reaction can be reversed. So H2 plus O2 goes to H2O. Let's balance that out. Okay, so that reaction can go in the forward reaction and make water, but it can actually be reversed then and go back and make oxygen and hydrogen. Okay, irreversible reactions cannot be undone. Whatever has occurred is permanent. Okay, and then there use an equal sign instead. Okay, and that uses an equal sign. So that's exactly, you cannot is permanent, you cannot be undone. Okay, and sometimes this is referred to as a chemical or a physical reaction. Okay, so a chemical reaction is when the atoms are rearranged and new substances are made. It's usually an irreversible reaction. Okay, physical change is normally reversible, in which new substances are not made. Okay, so it's maybe changed, but new substances are not made. Okay, so let's look at this in a little bit more detail. Okay, so physical and chemical changes. Here's some examples. You might want to note these down. Not easily reversed. Okay, a new product can be formed. The reactants are often used up. Often you see heat, light, sound, or fizzing occurring. Electricity may be produced. A precipitate. Okay, so a precipitate is like a solid being given off, okay? However, with physical changes then, they're easily reversible, no new products, often just a change of state, e.g. ice melting. So we'll look at a couple of examples then. Okay, ignore the line, there we go, running through it. So a chemical change is when new products are formed. So combustion, when you burn wood, so when something's rotting, rusting, so you can see the rust is made, and then digestion because you make new products. Okay, physical changes then, change in form but not chemical identity. Okay, so even though we're melting a lollipop, it's still a lollipop. Even though we're shredding the paper, it's still paper. Even though we're chopping the wood, it's still wood. And then when we're boiling water, it's still water, even though it may be steam. Okay, and then finally, just to get this in your heads, the kind of differences. So chemical, this is wood before, then we burn it, that's known as combustion. And that produces ash, okay, which is a new substance. Whereas we've got a physical one here, before it's a lemon, during the reaction it's sliced, but after it's still a lemon, okay? So within your notebook now, okay, or on a table, it's up to you, I'm going to show you a series of reactions, and I want you to think about, are they a physical or a chemical reaction and why? So I'll do the first one with you. So baking a cake, that's a chemical reaction. Okay, reason for this, a new product is made. Reactants used up. And you can't reverse it. Okay, so that's baking a cake. So that's the first one. The next one then, and I'll just do this one as well, boiling water, okay? This is a physical reaction, okay? Nothing new is made. It's just a change in state. Okay, and can be reversed. Okay, so on yours, or if you watch the end of this video, there's a load of other ones to have a go at. I'm not going to help you with everyone, okay? So you need to think about melting an ice lolly. Is that a physical or a chemical change? Burning wood, is that a physical or a chemical change, and why? Dissolving sugar in water, is that a physical or a chemical change? Fruit rotting, is that a physical or a chemical change? Eating and digesting food, physical and chemical change. Crumpling a piece of paper, physical or chemical change. And then burning magnesium, a physical or chemical change. So you're either going to create a table which has got physical or chemical and why, and then you're going to write each one. Burning magnesium, okay, that's the first one. You have to kind of pause the video as you go, okay? Or you're in your class notebook and you've got each one, so you can pause the video and look at each picture, okay?